Good morning, everyone. Thanks for having me here. My name is Ratsimbazafy, and I work as a data coordinator at Amundsen-Science. Before we diving into the data subject, I would like to give a brief introduction about the ship where these data were recorded. The Canadian Coast Guard ship Amundsen was built at 1979 under the name Sir John Franklin. It is owned by the Canadian government and used as a Coast Guard as an icebreaker. It is refitted as a scientific laboratory in 2003 to support research in the Arctic Canadian. It have passed more than 2,600 research days at sea and traveled about 300,000 nautical miles. So since its inauguration as a laboratory for the North, there is ArcticNet that have the mandate to support the expedition of the ship before Amundsen-Science took over on 2017. Amundsen-Science is a nonprofit organization hosted at Université Laval, and it is primarily funded by the Canada Foundation for Innovation through Université Laval. And it does have the responsibility for the scientific mandate of the research icebreaker CCGS Amundsen. So many of you might have already seen this picture. Here we have an overview of the instrument available on the ship for data collection for each expedition in the Arctic. The instrument records mostly physical, chemical, biological, and geophysical data, and plus other data like video and photo that are taken by the ROV, the small submarine in here. It does record images of the environment under the sea, and it does have the capability of doing coring on the seabed to sediment sampling. So here is an overview of the type of the data that are collected. They are mostly depth profile, and the time series. We published the scientific event log data, which is mostly metadata instead of real data, but we publish these to support users on documenting their the data that they will use. So all of these data are now published under Polar Data Catalog since the 2003. And along the years, files have been collected and increasing in the size. So users started having issues on finding the fraction of the data that they are looking for. So they have to download the whole archive to be able to just retrieve a few fraction of it. So we started then to think again, like, okay, how do we come around these issues? So increasing the fair compliance, we map the vocabulary that are used in this data. The vocabulary used in there so far is the GF3 at the year 1980s, And we mapped this vocabulary into new standards that are available. We kept the ISO 19115 metadata that already applied to this data at the Polar Data Catalog. And to have everything disseminated through an OpenDAP server to give the opportunity to users to access the data in a more detailed. So here in the right side is the general workflow of the data from the raw data until they are published as processed data. So the working we have done now is from here, vocabulary mapping as the already published data at the Polar Data Catalog are already processed data, but needs to be standardized in the vocabulary names. So we retrieve this data and map them and convert them into NetCDF in order to have them ingested into server ERDDAP. The figure you see in the right side in here is not actually a real measure, just an illustration of how ERDDAP would enhance the use of bandwidth once retrieving data. One of the benefits is the data access and interoperability, as the data are standardized before ingested in the ERDDAP. And on that platform, there is many available formats that user can choose to download their data. And before even downloading the data, you can have a visualization of what you are going to download. So here is the new model that we are working to publish with data under an OpenDAP server. The data are stored as NetCDF at Université Laval at an AWS Amazon storage object hosted by Université Laval. And the data stored in a bucket and then injected into a virtual machine where CCAN and ERDDAP lives. We put them in a container, so if something happened to the virtual machine, we can regenerate everything without trouble. So having this ERDDAP and CCAN accessible on the website of Amundsen-Science, we kept the part here external data platform. You are going to see that it's a Polar Data Catalog that we are keeping in there because the data have this DOI. It's a unique identifier. So it is not in the conception of this to be changed over time. So we had no choice than to keep the DOI and then redirect the users at Polar Data Catalog. But as we are going to see in the next slides, they will have access to ERDDAP if they want to retrieve subsets of the data they need. And this part in the left in here is to put everything discoverable at the SciUS portal. SciUS is a Canadian integrated ocean observing system. It's a national portal to explore oceanographic data in Canada. The metadata are managed using the CCAN. It is available in this address, but we still have some fine tuning in there. So if you go in this address, you might ask an user and password to get access there. But once everything will be polished, working fine, people can easily access to that. And as you can see here, we kept this. Now the expedition is organized as several parts. And each part, we call them leg 1, leg 2, leg 3, etc. And in each leg, typically 28 days for the ship to change crew. And we keep this in order to, it's a manner to keep track of the research project attached to each data recording. So that's why we keep it this way. So everything would be easy to looking for, depending on the leg part. If you are already know how the expeditions works on the ship. So people have participated in the expedition can right away say, okay, I was on that leg of this ship, so I can go directly in here. But for people, general users looking for data, they can use keywords to look for the data. And as I talked in my previous slides, we have here the DOI of the data that's still pointing to Polar Data Catalog. And when you enter inside the link ERDDAP, you have this view of an abstract of the data, and you can follow the link in Explorer here to go to ERDDAP directly. So this is just to show the number of data that we have been able to put up there so far. And okay, here is a general overview of the capability that we think that would be very helpful for users to find data, to interact with the data, and to have more choice of data format. Another important thing that I didn't mention yet is the possibility to do a programmatically request for the data. So you can easily go there to retrieve the data. So in conclusion, we have been able to put this data on ERDDAP, and by late of October or beginning of November, they will be available online. The next step, as I mentioned, is to join the SciUS portal to map discoverability of the data. The second point here is for another talk. We are thinking to make multi-beam data open for public access as well in this talk. So that's all. I want to thank these people for organizing the meeting, and thank you very much for your attention.